afternoon, guys. This is a question, uh, why, GCE question, I think 2015, 2011, and one of my private lesson students had this question in their mock exam. So let's see how we can handle a problem like this. The question is, the table below shows the pointer reading of a spring balance when different weights are hung on it. Determine the value of F. And here the weights are 5 Newton, 10 Newton, and F Newton. Of course, the corresponding pointer extension readings are 8 cm, 12 cm, and 30 cm. Now, if you have something like this, of course, there are different methods one can use to approach it. Someone may try to do substitution. Another person may use graph method. Another person might like, okay, why don't I make linear equations out of this and solve simultaneously? Okay, guys, let's see if we can try at least two out of these methods. Okay, if we want to try the graph method, we need to remember the key expression as a guide. From Hooke's law, we know that applied force is proportional to extension, provided the elastic limit is not exceeded. If we remove the proportionality expression, we put the proportionality constant K, and that is this stiffness of the spring, of that spring balance, or the force constant, or constant of elasticity of the material. You know that when you plot a graph of F against E, you are going to get a straight line graph passing through the origin. That means the slope of the graph of F against E, change in F over change in E, will give you the K. We are saying that the slope, which is now K, this K here, is the slope of the graph, is going to give you F2 minus F1 over E2 minus E1. Now, using that expression, we see that this K, I'm going to pick two force values there. The first force I will pick is 10, minus second force is 5, over the difference of their corresponding extensions, 12 minus 8, because that will give 5 over 4, that is 1.25 Newton per centimeter, since our extension is in centimeter. Now, how do I find F? I'm going to pick another two force points, and one of them must include F. And the ratio of these differences must give us this K, the same K, because it is the same spring. Of course, we know the value of this K already as 1.25. So we can say for another case, the K is, I'm going for F now, minus, let me choose F and 5. F minus 5 over, go for their corresponding extensions, 30 minus 8. That will give you F minus 5 over, this is 22. Now guys, now don't forget that K is already 1.25. So with that, rather than writing K now, we write 1.25 is equal to F minus 5 over 22. So F minus 5 is 22 times 1.25. Okay, when you multiply 22 by 1.25, you have 27.5. So F minus 5 is equal to 27.5. Now we need to get the value of F, which will now be 27 minus 0.5 rather. Minus 5 crossing to the other side of the equal sign becomes plus 5. So this becomes 32.5 Newton, and that is the value of F. Of course, if you use F and 10, you will get the same answer. what if somebody wants to say, okay, let's make equations out of this? Yeah, I think that is kind of possible. Now let's look at this from f equal to ke. We can say this f we have in the table minus 10 is equal to k into the extension between f and 10 is 30 minus 12. So we have f minus 10 equal to, this difference is 22, so we have 22k. F minus 20 plus 22k crossing this side becomes minus 22k equal to minus 10 crossing. Okay guys, I think there was a little wrong value there. 30 minus 12 is actually 18, and that's what we're supposed to have in here. Sorry about that. Now, having used f and 10, can we use f and 5? Yes, that is possible. If we say f minus 5 equal to, from this of course, k into the difference of the extensions between f and 5. That will be 30 minus 8. We have f minus 5 equal to 30 minus 8 is 22, multiplied by k is 22k. Okay. Now, making this last expression look like equation 1, f, stay on the side you are at, plus 22 crossing to the left side becomes minus 22k equal to minus 5 crossing over becomes plus 5. We can call this equation 2. Now, solving equation 1 and 2 simultaneously, we have, this is equation 2 here, so I'll bring equation 1 under it. F minus 18k equal to 10. Remember, this is equation 1. Okay guys, equation 1 minus equation 2, f minus f, of course that would be 0, minus 18 minus minus 22, minus 18, make sure no mistakes with the signs, minus minus 22 give you plus 4 equal to 10 minus 5 will give us 5. Of course, there's k here. So we have 4k equal to 5. And of course, dividing both sides by 4. Let's just do that as simple as that. K equal to 1.25 Newton per cm. Now that I've gotten the right value of k as 1.25, how do we find f? We can go to either equation 1 or equation 2 and substitute the value of k. Either of them will give us, or should give us, the same. Now let me go for equation 1. I will say from f minus 18k equal to 10. F minus 18 times k is 1.25 equal to 10. So 18 multiplied by 1.25, 22.5. So f minus 22.5 is equal to 10. Therefore f equal to 10, still on the right side, minus 22.5 move to the right side of the equation becomes plus 22.5, and when you add that together you have 32.5 Newton per centimeter. So guys, this is the value of f. Of course, it's all about the method you are quite familiar with and you are comfortable dealing with. Either way, you'll arrive at the correct answer. I hope this will help someone.